I want to go over some of the guidelines in the reading, some rules of thumb about how we approach data analysis and how we make inferences from data analysis. This is all from the chapter reading, page 23, if you want to follow along, but I think it's really good advice and good stuff to listen to. So the first one is know the difference between practical and statistical significance and take those things into account. A whole other video for you to watch on the idea of practical significance, statistical significance, and power. But really, you got to pay attention to that stuff. The so what is the most important question that we ask. We can do all the data analysis in the world, but if we can't say so what's the usefulness of this, then I'm not sure it's really worth it. So consider that. The second one is this idea that sample size really does matter. And you can have too small a sample size, right? Too small a sample size means the test will not be powerful enough. We won't be able to get the information we need, or if we do, it will only be applicable to the particular population that the sample comes from, a very narrow population rather than a more general population. So sample size can be too small, but sample size can also be too big. And if we have too big of a sample size, then we have an overpowered test. Now we're finding statistically significant relationships that have no practical significance and can really overpower our stuff. So be aware of too big a sample, and certainly be aware of too small a sample. There's also a requirement to know your data. That means you really have to take a look at it. It's really easy with computer technology to just jump in there and give an order to the computer and tell it to do some stuff, and it spits an answer out back at you. It can spit some numbers back at you. But you really do have to become familiar with your data set. There's a lot of assumptions that go with all of our statistical techniques. You're used to some of them, right? So we make assumptions about normality, and normality of relationships is a great example of an assumption. Equal variance between different samples is another assumption. Well, we really have to know that those things exist, and so we really have to get in there and look at the samples and know them. Outliers, right? So there's no hard and fast rules about how to treat our data in every single situation, right? We'll go over some rules of thumb, particularly towards the end of the semester. We'll talk about some general guidance about how to deal with missing data, how to deal with outliers, and questions like that. But the fact is, it's going to change just a little bit for every data set. So you really have to know your data and get into it. Rule of thumb number 4 is to strive for simplicity and parsimony. You've heard Occam's razor, the simplest answer is usually the right one. That really applies in multivariate statistics. So look, the thing is, when we're creating these models, it's easy to add another variable. In fact, adding another variable almost always makes our model more predictive and more powerful. But there's a lot of danger that comes with adding more variables as well. For one, it reduces the generalizability of our results. For 2, it reduces the power of the overall model. And for 3, it becomes just so complex that it's not really useful anymore in any kind of predictive way. So we really want to avoid that where we can. We want to look for as simple a model as we can. Now, that being said, there's certainly, in today's research world, there's certainly, and in today's selection and training and hiring world, there's a lot of reason to use complex models. But only use the simplest model that you can in order to get the answers that you can. You should always lean towards the most simple model you can find because it's really going to have the most explanatory power. We'll also talk about later in the semester, there's issues about having variables that are too closely related to each other in a model can really skew some of your interpretation in a problem we call multicollinearity. Don't get into that right now, but that will certainly be an issue later on. Another rule of thumb, which is kind of important and people forget about a lot, is the idea of embracing our errors. So, look, we're going to make errors, and there are going to be errors in the data, and that's not really what I'm talking about here. What I'm talking about is there is an error to every multivariate equation, right? So if we just do a regression equation, we get a y variable, the outcome variable is equal to a predictor or x variable plus some error. Right, and that error is about how our predictor doesn't quite get us there, that there's something else out there. So I know I just said be parsimonious and try to keep it as simple as possible, but also be aware of that error, and particularly as errors get larger, take a look at them. That's a place for investigation and trying to figure out what's going on so that we can create better models. The reason we have multivariate regression is because we started with just bivariate regression, and we say, you know what, there's probably something more to this. there's some error that we're missing here, and maybe it's systematic, and maybe we need to take a look at it. So don't be scared of errors. Actually look at the errors and try and figure out if there's more information there that we're missing. Another rule of thumb is to always validate and replicate our results. You may have heard, and if you Google it, there's a whole lot of information out there about a replication crisis in psychology. And that mainly comes from people not replicating results and just trying it with one sample at one time and saying, that's good enough. And that provides ground level truth going forward across a really generalizable and across a lot of different populations. And the fact of the matter is that causes a lot of problems in our ability to predict. We need to replicate results across different populations. What works in one workplace may not work in a different workplace. What works with one group may not work with a different group. We really need to take a look at that, and we really need to validate our models in the particular population that we're interested in the workplace that we are working in. So those are some rules of thumb. Like I said, they're all in the reading, and they provide a lot more detail there. But I think it's worth taking an overview, and it's stuff that people don't normally think about when they start studying, and particularly it's easy to think about them now, but when you finish studying multivariate statistics, maybe I'll post this video again at the end that we can look at it again and remind ourselves of these rules of thumb that are going to make us better researchers, better scientists, and better psychologists.